Welcome to beautiful data. So what you're looking at is data. It's not pretty, a long way from beautiful. Today you will see how to take data like this and make it easier to look at, more valuable, and more beautiful. Thanks for joining me here today. My name is Michele. I work as a pre-sales consultant for Tableau based in London. And I'm not English, as you can probably tell. I grew up on the streets of Venice, Italy, if you can call them streets. I watched a lot of American movies when I was a kid. My favorite one, Jurassic Park. I dreamed of, Jurassic Park. Many people like it. I dreamed of becoming an archaeologist, digging and discovering dinosaurs. My career took a slightly different path that led me to this stage today to share with you how Tableau is a revolutionary way to look at data. It kind of all worked out, right? I can say I'm a data archaeologist now, digging and discovering data insights. But anyway, so part of my job is help people transitioning from traditional BI platforms to a completely new way to look at data and to show them the right way to do so. And only at that point, your data will become beautiful. And I want to demonstrate this with a couple of examples. A couple of notes before we begin. This session will be recorded, so you will be able to find it in the Tableau conference website soon after conference. I will be using one workbook. You won't see PowerPoint or text or anything like that. I will be using different data sets, approaching them, analyzing them, using different techniques. And you will be able to download this workbook as well. So don't worry about taking notes. Sit down, relax, not too much, and enjoy the session. So to demonstrate what I was talking about, I want to show you a first example. So this is a travel agency with some data on different destinations. So what they want to find out is which country is the most popular to plan the advertising on their website accordingly. So they thought, we'll define popularity with these four metrics: the number of bookings, the revenue, the room nights, and the search. So the number of searches that people do on their website. And I can even weight these measures. For instance, if revenue is not that important for my business, I can put a weight of 0.5, and same for the room nights. And in a non-Tableau world, you would have to take these ingredients, mix them up, and come up with a number. A number that's going to be my KPI that defines the popularity of my destination. And this is exactly what I've done here. So if I go to measure, I have popularity. And my popularity tells me that, in this case, Greece is the most popular, followed by Spain, Turkey, Italy, Portugal. I wanted to pay attention to the number 7, Egypt and Cuba. So according to my KPI, I should treat them the same way. I should plan my ad campaign the same way for these two countries. Now, instead of looking at one number, look what happened if I look at all my metrics on the screen. So I'm going to use the rank of each metric and them on color and maybe as circles. Now I can quickly see that when it comes to number of bookings, the best rank is Spain. So Spain is the best when it comes to number of bookings. When it comes to revenue, that's Italy, because everything is so expensive in Italy, right? etc. When I have this type of chart, by the way, I can group points that belong to the same country, in this case, together, using a lollipop chart. And I'll show you how. So I'm going to duplicate rank, and one of them is going to be a line with a measure name on path and nothing else. At this point, dual axis, synchronize, and let's say I want the best on top. So I'm going to reverse the axis. And I will come to, in 1 second, to the conclusions that this graph can draw. But look what happened if I still use the same KPI, popularity. The KPI is the same for Egypt and Cuba, but they behave differently, much differently from each other. Because Egypt is very good when it comes to number of bookings and revenue, while Cuba is very good when it comes to searches. And if you think about these metrics, number of bookings and revenue, they're a measure of the past, because they already happened. While searches, they are an indicator of the near future for that destination. It means people are looking for holidays in Cuba, in this case. And so you see that even though I have one number that tells me they are the same, they're not. And this is a good example of what I mean with beautiful data. It's more meaningful. It's more beautiful. It gives me a lot more of insights just by looking at data in a more visual way. Does it make sense? Now, you might be thinking, that's easy with 4 metrics, 20 countries, a couple of 100 rows. Who's thinking this? Raise your hand. Who's dealing with much bigger data than this? So you're right, you can't do this with that data. You have to find a way to make very granular information surface at a level that is understandable by humans, by us. And a good example is using stock data. Stock data has typically a lot of data points, a lot of noise, fluctuations day by day. I have to find a way to deal with that data to get insights. Here I have another data set where I can take a look at the close price, the average close price, in this case, by day, for different stocks. So my goal here is to understand, to find out which stocks are the most volatile and which other stocks are the least volatile. So I might go and grab ticker, use it on color, and you see that I have quite a lot of data now. And I can't, as a human, compare something that says 800 with something that says 400, 100, etc. I can't draw any conclusion out of this. But since I'm good at Tableau, thank you, I know that I can apply a percent difference to see the percent difference day by day and see if there are any days where I had a significant growth or not. And I end up with absolutely nothing. It's useless. I can kind of see something, to be honest. I can see NVIDIA is quite volatile. Is it from NVIDIA here? One person. It's growing, though. It looks like it's growing. But I have to find a way to get rid of this noise. And a good way when dealing with stock data, especially, is to use a moving calculation. Moving calculation allows me to see the overall trend, to filter out the noise given by day-to-day fluctuations. So I'm going to edit this table calculation. And this time, I want a moving calculation, moving average, of the previous 30 days, excluding the current value. And I can kind of see the overall trend much better now. And now, on top of this, I can add a % difference. And now, yeah, kind of makes more sense. I have some insights. You've seen NVIDIA. We also got Twitter. It's quite volatile. We have Chipotle. We can identify some of them. On the other hand, we can see that Apple, Adobe, Amazon, they're quite stable. But this is not a great way to look at this data. So I thought, I have to find another way. And if you consider all these person variations, single points, I can think of grouping them and binning them into bins of from 0 to 0.1%, from 0.1% to 0.02%, and see how many days fall into each of these bins. And this is what I've done here. This is exactly the same data. You can download the workbook and see that I'm not cheating. It's the same data, just arranged in a different way. So here I can say I want the previous 30 days. And I can see different histograms with the frequency of days with the variation between -1 and 0, 0 and 1, etc. And this gives me already some good insights. For instance, if you look at, let's say, Adobe, I can see they're pretty much concentrated around 0%. It means that it's quite stable. And also, when I deal with the very granular data, it's still a good practice to find an indicator of what I'm looking at, of what I'm asking my data. And in this case, it's the standard deviation, because the standard deviation is a good indicator of the volatility of each stocks. And for instance, I can see that Twitter down here, it's quite dark. It means it has a high standard deviation, and it's quite dispersed. And so I have some good answers already. And from here, I can drill down. So I can highlight these days, have them highlighted on a trend line still, and even have a table that tells me when this variation happened. So in this case, I've started from a higher level, found a way to understand my data, and then I drilled down from there. And this is much better, in my opinion, than this. Do you agree with me? Sure? Who doesn't? Nobody. Great. So this little introduction lead to an agenda. So we're really talking about two subjects today, two topics. The first one, which you saw in the first example, is dealing with data structures that are not optimized for the questions that we are asking to our data. And in those cases, you have two options. You either stick to your method until you get there, until you obtain your number, or you change the way you present your data. And Tableau allows you to present your data in a much more visual way than just a number. The second topic is dealing with data that's inherently noisy, like stock data, like we will see other type of data. And in that case, we have to be able to take this information and make it humanly consumable. And we will see how. Let's dig into part 1. This was a question from our community. And in this data set, I have different campaigns, marketing campaigns, run in different countries using different contracts. And in each row, I have country, a contract ID, a start date, and an end date. What I want to find out is how many days a given campaign has been running in a specific country, or in other words, how many days in each country I had at least one contract running that campaign. This seemed like a very easy question to answer, but the data structure doesn't allow me to answer this question easily. Because if I had a non-event-based data structure, let's say 1 day per row, and the indication of how many contracts are running on that day, this would be a question I could answer in 2 seconds. But I have an event-based data structure. So anyone has an idea why this question is hard to answer? Can I sum up the different durations? Why can I not just add the different durations? Overlapping, who said that? Yes, exactly. Take these two. I can't just add them. I can't add this duration, because I would end up double counting the same days. And that would give me a wrong answer. So I need to find a way to avoid double counting days when I have overlaps. And I will show you how. This is my data source. I have country, and then I have a start date, an end date, and let me drag contract ID as well. And then I have the duration, which is a really simple measure. That's just the number of days between the start and the end date. And I'm going to add it to columns. Now, let me bring Germany on top. That's a good example. The first thing I noticed here is these two contracts. They have the same start and end date. So I don't want to double count them. And so I can just take contract ID and remove it from the visualization. Let me resize this a little bit. Now, another thing that I see is sometimes I have these dates that share the start date. So I have the same start date with different end dates. And in this case, what I have to do is to take the maximum of these two, because the first one is completely overlapped by the second one. So I don't want to take the first one. So I'm going to go to end date, select measure, and I want to take the maximum. And now I have some good pairs of start and end date that I can work with. And I've created a campaign days measure, and I'm going to show you what it does. It's very simple. I'm kidding. It's not. But let me explain it to you. So for each row, I want to find out how many days to count. And the first condition is if I'm considering the first row, I don't have any previous contracts, so I'm just taking those days and summing them up. I'm going to take them all. That's the first condition here. The second condition is if the maximum, oh, I forgot to bring something in the view. I'm going to use a running maximum end date. And you'll see that that represents the date that, has been covered so far. So let's say the right limit. Let's say in this row, I've covered up to the 27th of February. And let's take this one. Here, I know I've covered days until the 1st of March, 2014. The contract that comes next starts on the 11th of March. It means there's no overlap at all. So in this case, this is another condition. I'm going to take the whole duration of the contract and sum it up to the previous number. And here I have 20 plus 12. That makes it 32. So that's the second condition, no overlap. The third condition, of course, is where I have a complete overlap. And happens in this case. In this case, I'm considering the 1st of March, and I know I've covered up to the 1st of March again with my campaign. And the contract that comes next happens between the 23rd of February and the 25th of February. It means I have already counted those days. And so whenever the end date happens before the running maximum date, I'm not adding up any day at all. In this case, it's 20, and 20 remains. And the fourth case, perhaps the most complex one, is where I have a partial overlap. Like in this case, the running maximum date is the 27th of February, and the next contract begins on the 21st of February and ends on the 1st of March. I have a partial overlap, like the one that we saw on the first page of this example. In this case, I have to take the days between the 1st of March and the 27th of February. That's just 2. And I'm going to sum them up to 18 to get to 20. Once I find out all these conditions, now I can just take off everything else that I don't need. And let's say, oh, there's one more thing. Sorry, let me go back. It's a data night out effect. So of all these numbers, I want to take the last one. That's the number that I want. It's the number that represents the number of days that my campaign has been running. So for that, I'm going to use a last filter and only take the last one. And at this point, I can get rid of everything else and finally have the campaign days by country. This was too easy, maybe. Really, I don't deserve this applause. This was way too complex. It was way too complex to answer a simple question. So why, instead of breaking my head in finding the right calculation, don't I physically overlap the contracts on the screen? So I take advantage of the data structure that I have. In this case, let me draw a country and contract ID and start date and the duration. This is a Gantt chart. With this data structure, it's very easy to build. And let me add the end date as well in the tooltip. At this point, I'm at 2 clicks distance to my answer. That's 1. And that's actually 3. 2 and 3. And let me fit the entire view. And maybe I also want to use the start date, maybe month. And this in 5 seconds gives me exactly the same answer that I was looking for. Because I know that in Germany, no contracts have been running in April and May, except one between the 30th of April and the 1st of May. In Switzerland, the same. I only have one contract in February, no contracts in the UK in April. I can draw many more conclusions this way. And it gives me the same answer, it's the same data. It's just a much simpler, much more informative way to look at the same data. Do you agree with me? Yes, great.
Can you redo that 3 simple steps again?
Sure. I repeat it. So, first of all, let me draw a country. Then I'm going to use contract ID. And then when I have a start date and end date, a Gantt chart is a good chart that you can create. So in this case, I'm going to use a continuous start date. And I'm going to use duration on size. And now from this, take contract ID, move it on to detail, fit the entire view, and add some transparency. So this, again, is a much simpler, much more informative way to look at data, at this data. So we've seen this example is the one that I've just shown you, deal with the time series data, event-based versus non-event-based. Sometimes I have a different issue. Sometimes my answer needs a level of detail that's not in the data. And that happens when the data has been pre-aggregated. And this is a good example for it. This is healthcare data where I have different diseases and different ages and the number of patients in that contracted that disease at that specific age. What I want to know is, what is the median age of patients by disease? Looks like a question that I can answer in 2 seconds, so I'm going to try that. I'm going to use disease, age, and I'm going to take the median. And it's always 40. Why? Anyone? Okay, in this case I have different diseases, and it's always 40. So the reason is that I need the patient level of detail. I need a patient ID, a patient name, something. Because now I'm taking a median of something that's this. For each disease, I have 80 rows for 80 ages, and the median point is always 40. It's always that age that leaves the same amount of rows or ages on its left and on its right. And in this case, it's 40 for every single disease. And you can imagine that it's not the right answer. I need the patient level of detail, and I don't have it. And that's so common, especially when dealing with sensitive data. Maybe that level of detail has been taken off, or maybe for performance reason. Sometimes I want my data set to be faster, and so I eliminate a level of detail. Or maybe I'm using cubes. How many of you use cubes? How do you guys feel about it? Yeah, I feel that as well. So I need to find a way to figure out what's the median. So let me start. Here, I have different diseases, different ages, and the patient count. Pretty easy. Of the patient count that I've duplicated, I want to take the running total. And I want to compute along different ages. Now I have some numbers that ranges from 0 to the total patient count for that specific disease. Something like this. Next, I want this to range from 0 to 100%. I want a cumulative distribution. So I'm going to add a table calculation to this running total that's going to be a percent of total, computing age and partitioning by disease. And now I have numbers that go from 0 to 100%, from 0 to 100% for each disease. And now I know that the median age is where this distribution crosses 50%. That's the median point. And for acid reflux, it's 49. For chronic bronchitis, it's probably 59. I can do that manually. I don't want to, though. It's too clunky. Imagine having hundreds of diseases. So I'm going to define it in a formula. So whenever this cumulative distribution becomes equal or greater than 50%, then I'm going to take the maximum age. I'm using maximum just to avoid that very annoying error, you know, the huge red line that sometimes appears in my calculation. I hate that. I could have used min as well. And this I wanted to compute using age. And now I see that it's always null until I have my answer. That's 49, that's 26, etc. Of all these bars, I want to take the minimum because that's my answer, that's my median. So I'm going to go back here and take the window min of this expression. And this, again, is compute using age. This gives me my answer. So it's always 49 for acid reflux. It's 26 for asthma, etc. Of all these numbers, I want to only take one bar. I don't want to repeat the same numbers over and over. So I'm going to use a condition that says first equals 0. It means I only want to take the first row per each disease. And this must always be true. And now, the best part, take off everything else. And finally, I get to my answer. This is the median age of patients by disease. Does it make sense? I don't deserve this applause. I only need it for drink some water. So why don't I use my eyes to assess where's the median? How? Let me use the patient count per age. Easy. Disease on color. Lines. Now, of this, I want to take the running total, and I still want it to range from 0 to 100%. So I'm going to add still a percent of total using, oops, age. What was that? Well, and now I already know where my answer is. It's just there. Finished. Stop. And if you don't trust me, I'm going to make a test. This is asthma, and I can see age 26 is where it crosses the 50%. And if I go back, it's 26. Yes. How about that? It's 61 for emphysema, and it's 61 as well here for emphysema, etc. It's the same data, just more visual. Plus, look at these two diseases, rheumatoid arthritis and hypertension. They have the same median age, that's 56. Are they the same diseases, though? Look here, rheumatoid arthritis and hypertension. I can draw some very important conclusion from here. And the conclusion is, rheumatoid arthritis starts very, very early in the age of patients, almost when they are 1 or 2, while hypertension doesn't really start until they're 18, 20. This is very important information, and I couldn't get that information before. So here I have my answer plus additional insights. And that's where the added value of using a tool like Tableau comes out. Great. This leads to the second part, which is the real fun, because it's really bad data. It's not really bad. The first example actually uses a data source that not many know about. It's called Superstore. It's in Tableau Desktop. And we want to know what type of customer does the majority of Superstore comes from. We already know that tables in the East, they just don't work, right? It's an inside joke. But we have hundreds, thousands of customers. How do we find what's the segment of customers that is the most profitable for our business? How do we aggregate these 1,000, 100,000 of customers in a way that's easy to interpret for humans? Let's give it a try. I'm going to use Superstore and customer name. And let's take the order date. And I know where, when they purchased. And also I want to know how much they spent and how much profit my business got from those transactions. So you can see that I have too much data. I can't see any clear patterns of seasonality or anything from here. So look what happens now. I'm going to change the background to black. I'm going to change the color to yellow. And I'm going to change the type of mark to stars. Yes! This is beautiful data. Is somebody leaving? Okay, so the next example, no, I'm kidding. Combo. So I need to find a way to take this data and look at it in a way that's meaningful. And I'm going to take this. I have to use something that's called LOD calculations. Ooh. How many of you use LOD calculations? Yes, very good. So actually, they were invented for this type of use case. For when I have data that it's really granular and I want to be able to look at it, changing the level of details to a more understandable level. That's why they were originally thought for. So now I have to think, how do I define customer behavior? Maybe the number of orders they made, maybe the order size, maybe they purchased many times, little purchases, maybe just one time, but a big one. So the first thing that I want to look at is the number of orders per customer. And you know Superstore, right? So anyone? Hint, it uses a fixed. First row, come on. Fixed on? Customer. Oh. Fixed on customer name. What then? Yes, exactly. Count distinct of order ID. And a good thing about the fixed is that it can be a dimension. So I can take that number of orders per customer, drag it into my dimension pane, and use it to segment my population. Now I see that I have customers that purchase 1, 2, 3 times, up to 18. And I can see how much revenue is coming from each of these segments. So this is a good way to look at my business. I see that the majority of revenue comes from customer who purchased 7 times. I would have expected customer who purchased a lot more often, but it's not like that. So maybe the next question I want to ask is, what's the average order size per customer? Do they make big purchases, small purchases? What do they come to my Superstore for? So I'm going to create a new worksheet, and I'm going to create a calculation called average order size per customer. But first, as you know, Superstore is not at the order level. It has 1 row per item per order. So first of all, I need to calculate the sales per order. Anyone? Now that you're warmed up? Fixed? Yes? And? Yeah, perfect. Very good. Very good crowd today. Now that I've got my sales per order, I can calculate the average order size per customer. And again, this is similar, so it's a fixed customer name, and that's the average sales per order. Now I can take the average order size per customer, again, move it onto dimension, and use it onto rows. But this is an average. I have a lot of values. So the next step is to group them into bins. And I can simply take the average order size, create some bins, let's say of $100 width, and use that instead. And see where the majority of my revenue is coming from. And in this case, it comes from this segment. Customer whose average order size is between $600 and $700. And from this segment, customer whose average order size is between $700 and $800. And I can also group all of these bins together. Maybe there's something going on there. We will see later what's going on. But let's group them for the moment. Let's group them into one bin. Now I have a pretty good idea what's going on in my business, but the real magic happens when I cross these two distributions. So let me use the average order size per customer and the number of orders, and let me create my personal favorite visualization. That's a nice heat map. I can also change the color to highlight the most profitable segments. And once I build this is a very good insight into my business. I see the most profitable segments per average order size and number of orders. I see the ones that maybe I should promote more or tailor more with campaigns or anything. And I can also add the marginal distribution. So it's the two visualizations that I've created earlier. They're still useful because they're marginal distribution of my heat map. And so this is a much better way than a starry sky, maybe, but it gives me a lot more of information. And if you're wondering why this segment is not generating much revenue, that's people that purchase 11 times and spend more than $1,200, I can drill down and see that it's only car. It's only one person. And that's why. So again, I applied similar concepts of my stock data. I've been able to make this data, this information surface at a higher, humanly understandable level, and then I drill down from there, not the other way around. That's how I recommend you to do it. Great. Does it make sense? Do you like it? Great. Fourth example. This comes from a customer. They do engines for aircrafts. And just that you know, an aircraft engine is made up of more than 30,000 single components. What they want to look at is how often they replace these components, because these components got to be replaced. They don't want to replace them too often to avoid unnecessary costs. They don't want to, they still want to replace them often enough not to have any risk where the engine is in use, of mechanical failures, for instance. So they have these 30,000 components. They want to see the rate of change, so the relationship between the number of hours flown per number of replacements. And I thought, I can create 30,000 time series, put them on the screen, they figure out. I thought. Then my account manager didn't like it. So I had to find a way to take these 30,000 components and find out when the relationship between these two variables, number of hours flown and number of replacements, is nonlinear. Because that's when we have a problem. There's something going on. So I identified the nonlinearity. Now, I don't have that data, unfortunately, but I'm going to use some similar data. It comes from the word indicator. It's included in desktop as well. And there are two variables, internet usage and mobile phone usage, across the last decades for hundreds of countries. So instead of having 30,000 components, I still have hundreds of countries. I can't create 200 time series and put them on a screen. So if this doesn't make sense at any time, always remember what's the original use case, because that's a very business-focused use case. So this data set has hundreds of countries, the last 10 years, internet usage and mobile phone usage. I'm going to highlight them and show me, recommend to use maps, because maps are cool. In this case, I see some blue blobs that become darker and darker and bigger. They give me some idea what's going on, but nothing about the relationship between these two variables. But I know how to use Tableau, and I know that a scatter plot is a good way to look at the relationship between two continuous variables. And so the scatter plot, what does it tell me? It tells me that it's growing. Both internet usage and mobile phone usage are growing, maybe with the internet usage a little faster than the mobile phone usage. But again, nothing about the relationship between these two variables. So I can try and connect what it's called a connected scatter plot. I have a bunch of lines, and each line represents a country. And I can see that Canada they have a pretty linear relationship. For, let's take a look at something else. For Greenland, Greenland maybe something wrong going on there around 2007. I can take a look at all of these lines. This is Finland, it's pretty linear, so I can have an idea of whether the relationship is linear or nonlinear. I can even look at them on top of each other, because that's much easier. But again, this is 30,000 time series on the screen. I don't want this. It's useful, but it's clunky. I don't want to scroll down to take a look at them all. So here I have to stop and think. The same way I thought about customer behavior, number of orders, average order size, what's that identifies nonlinearity? It's a correlation. It's the correlation, and in Tableau, it's really easy to calculate. So let me create a new worksheet, and that's from Tableau 10.2. We introduced a function called cor for correlation. So I want to calculate for each country what's the correlation between mobile phone usage and internet usage. And I'm going to call it country correlation. And this country correlation gives me some good idea of the countries where the relationship is nonlinear. For instance, here I have the Bahamas. The correlation is very low. For the ones of you who are not familiar with correlation, the closer it gets to 0, the more nonlinear is the relationship. So I want to identify the point that have a low correlation. I still have hundreds of countries, so let me display them circles and group them by region. Do something like this. Also use region on color. And when you have something like this is a popular visualization. It's a good practice to scatter the points around so they don't overlap. You can do that, this is a little tip, by using an index and compute the index using what each point represents. That's country in this case. You end up having something like this. That's more understandable. You probably want to make the axes independent and hide them. But the point is, if I go back to, to my use case, is I have my answer here. Because I know these points, these countries, or maybe these ones, are the ones that have non-linearity. And imagine having thousands of points for thousands of engine components. You can identify the anomalies in 1 millisecond using your eyes. That's much better than having time series. And again, I've been able to represent this information at a higher level. I can drill down now from there. So I can create a dashboard, use what I've created here, and use still my time series, using my visualizations as filters. So let's take a look at these points. They are actually very, very strange. They have non-linearities. And you've seen I've done a pretty good job in identifying them, because they're non-linear. You could tell. But you could tell much faster now. I can make a test as well with the one on the right. And they look indeed much more linear. And this is a very good way to look at this data. And if you want to do something that's even more awesome than this, you can do something like this, where I can select points and see the different countries on the right. What do you think? Does it make sense? Now, I used to finish this session at this point, but people kept asking me, how do I create this kind of magnetic field? It's really awesome. Everybody wanted to know how. Do you want to know how? Yes. So, there are two concepts here. One is having all these time series making go to a new line. I want to create a matrix of time series. This is how I do it. Let's go back to our time series. So this is what we created earlier. And first of all, I need to determine what's the side of the square. And that's the square root of the number of countries that I have. Simple math. Let me show you. It's not this one. Let me show you. It's a simple square root of a count distinct of the number of countries that I have in my data set. And in this case, there are 200, so the square root is around 14, rounded up to the nearest integer. Then I have to create these two measures. They are row ID and column ID. The row ID, it's just an index divided by the square root and rounded up to the nearest integer. So let me show you what it does. First of all, I need it to compute using both country and year, because I don't want to get a value for each year, but I still want to compute a long country at the country level. So now I get one number per country. And here my index is 0. So 0 divided by 14 is 0. 1 divided by 14 is still 0. 2 divided by 14, still 0, etc. Until it becomes 14. And at this point, 14 divided by 14, it's 1. 15 divided by 14, still 1, etc. Until it gets to 28, and then it becomes 2, and then it becomes 3, etc. So index divided by the square root. The column ID is similar. It's just an index modulus the square root. The modulus, it's essentially the remainder of the division between the index and the square root, in this case. So again, I'm going to drag it onto my visualization and compute using both country and year, but I want one value per country. And so now, my index is 0. 0 modulus 14 is 0. 1 modulus 14 is 1. 2 modulus 14 is 2, etc. Until my index becomes 14. At that point, the modulus is 0 again. And then it becomes 15. 15 modulus 14 is 1, because 1 is the remainder of the division. And then it becomes 2, etc. So you've seen that using index divided by and index modulus by, I've been able to create some coordinates of row ID and column ID, 0, 0, 0, 1, 0, 2, 0, 3, etc. At this point, I don't need the square root anymore, and it's quite logical. I use row ID on rows and column ID on columns, and country, I just move it onto detail. And then I make it fit the entire view. And this is how you go to a new line. Row ID and column ID. Index divided by and index modulus by. As simple as that. I'm going to hide the header, because I don't need it. So that's the first step. We are almost there. Then I'm going to use a trend line. And I want to sort them in a way that it makes it look like a magnetic field. How should I sort them? By? Anyone? I should sort them by slope. Sure, somebody said that. Oh, you said that. Okay, so you're right. I have to use slope. And before 10.2, I might have used R or Python or complex formulas. But again, with 10.2, I've got a new function that calculates the covariance of two variables. So I can simply calculate the slope, country slope, as the covariance by country of these two variables, so mobile phone usage and internet usage, divided by, per country again, the variance of the x-axis in this case. So let's say internet usage. Here I've got my slope, and now it's really simple. Right-click on country, sort by field, country slope, descending. Boom! That is how you do it. So this ends my session. Thanks everyone for coming. Before you leave, I hope you enjoyed conference so far. Some conclusion, a recap of what we've done. So working with suboptimal data structure, lollipop chart, Gantt chart, visual median. Working with noisy data, stock histogram, customer segments, LODs, multiple time series, magnetic field. Important, change the way you present your data. Tableau allows you to do so. You will never break Tableau. You will never break your data source. Is there an easier, more visual way, a more informative way? Don't always stick to your numbers unless you've got to do it. And start at a higher, more understandable level of detail. Use LODs, use table calculation. So only at that point, drill down from there. Don't do the other way around, because that's not user-friendly, is not efficient. And please give feedback. It's really important that you give 5 or you don't do it. But seriously, it's really important. We are a data company. We look at this data to improve your experience in the next conferences. Hopefully you'll be there. So please, if you have any comments, if you thought the session was too difficult, too easy, too fast, too slow, please comment and leave a feedback. That's really, really important for us. Thank you. Thank you for coming. If you have any question, I'll be around for the next 10, 15 minutes. So feel free to come to stage and ask me anything, almost anything. Thank you.